For graphing y equals negative 1/4 x minus 3, you will need a ruler and graph paper. If you don't have graph paper and a ruler, you need to pause and go get your graph paper and your ruler. So in our last video that you watched, you heard that it was y equals mx plus b, 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 b. And we know that m stands for the change in y over the change in x. So we will write that down, and that is right here in our equation. And we looked at earlier that the slope is that number in front of x. Remember, we have to have our y equals by itself. If it's not, you need to get y equals, and we've done that before. A couple months ago, we practiced that. And once we get it, the x, the variable or the coefficient in front of our variable, that negative 1/4 is our slope. So we're going to use that in our graphing. So no longer do we have to make tables. We can use what we know about our equations now in y equals mx plus b, 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 b. And we notice that that b, it's plus a negative 3. So b is a negative 3. And remember, that was our y-intercept. So when we find that number, getting y equals and our variable x by itself, and our negative 3, remember that is a coordinate pair. We always write it as a coordinate pair. So write this down in your notes right next to your graph. We've got our y-intercept of 0, negative 3. So that's our y-intercept. So at y is negative 3, so that would be down 3. So over 0, because that's why x is always 0. X, let's write that down. X is always 0 for the y-intercept. This is our y-intercept, so x is always 0. So we move over 0 and down negative 3. So that's our y-intercept. Now our slope from that point, we know that our line goes through that point. Our slope is a change in y of negative 1 and our change of x of positive 4. So from that point, I'm going to go down negative 1 and to the right positive 4, because that's our change in x. So plus 4 for our change. And that is our next point. Now, we have to get more points. We can't just draw our line now, but our line goes through those 2 points, and we want to get more points over here at the edge of our graph. We want to go all the way as far as we can to get to the edge of graph before we go over. And then we also want to go the other direction all the way to the edge of the graph. So I'm just going to continue down 1 to the right 4 with my slope. Down 1 and to the right 4 and put a point. Down 1 and to the right 4. Oh, and I'm off. So it'd be somewhere over here. I'm not quite sure where because I don't have any more squares on my graph. But I want to mark that point because that's the point crosshairs that I'm going to use to draw my line. So now to go the other direction, I go backwards, left 4 and up 1. Left 4 and up 1. Left 4 and up 1. Put a point there. Left 4 and up 1. Left 4, and I'm off the graph. So these are my 2 points that I'm going to use to graph this line. So what we've done is we've noticed the patterns in our linear equations, and we're just using those patterns, the slope and y-intercept, to graph our equations, our linear equations, much quicker and more efficient. So we want to make sure we really line up those crosshairs to get a good straight line going through those points. And then we want to draw our line outside the graphs and putting arrows on the end, because If we miss the arrows, we're only drawing line segments, and here we're continuing them all off. So I'm going to check my points. It goes through that crosshairs, goes through the -3 y-intercept, and this point up here that we had. And that is graphing with slope and the y-intercept, with y equals mx plus b. So I always find it very helpful to write that equation, y equals mx plus b, right above my equation and line up my y-intercept and my slope.